So how does all of this work? How does the keyboard actually send 11 bits of data through two wires? It is actually using such a neat technique. The clock pin is the bit that tells us that we are accepting an input. Whatever the data pin's data is, that is what will be stored. For example, the clock will be sending 11 bits of data, so that means we only need the clock to pulse on 11 times. Each time the clock bit is high, we use whatever bit the data pin is sending during that pulse. So if we look at the chain of pulses, we can see what the code will be. So how do we extract this data? This is where the shift registers come in. The shift register works by accepting a single bit of data and a clock pulse. When the clock pulses, it stores whatever the data pin is. What is neat is that when there's a second pulse, it shifts the data from the first latch to the next latch, and then stores the new piece of data. The 74HC595 has 8 data output pins, so we can see what the data is in the registers. Since we have 11 bits, we need to use 2 of these chips. But now you may be asking, what is this third IC here? This is actually an inverter. This is because the clock output from the keyboard is always high and it pulses low. So we just invert this so that the pulse is going high instead. I hope you learned something new. I'll see you on day 25.